Hi, folks. Welcome. This is the Oracle Autonomous Database Learning Lounge. I'm Marcos Anasibia, part of the product management team for Oracle Autonomous Database. And today we have a very, very cool session on basically Kubernetes, right? So how to actually master the Oracle Autonomous Database Lifecycle using Kubernetes, right? So for today's session, we have Germán Viscuso. He's a director of community management in the Autonomous Database team. And he's going to be talking to you guys about, the advantages, right, of using the OraOperator, right? That's the Oracle Database Lifecycle Manager for Kubernetes, right? And he's going to be talking about, how that gives you simplified management, seamless integration with the API for Kubernetes, enhanced automation, and versatility in deployment as well. So we're going to have an open Q&A. So at any time, if you guys have questions, please make sure to type them in the Q&A box, okay, of Zoom. And we're going to distribute to you guys some links through chat, okay? So basically some important links just to begin with, right? We have the new Getting Started page with Autonomous Database. We now have added a new Spotlight section there. So you're going to see the things that we are spotlighting that month, right? So these are things like AI and ML. For the beginning of the year, you're going to see the things there, recordings, blogs, and links there, okay? Then you can join us on LinkedIn or X, but also, both on Stack Overflow for asking your questions, but Slack as well, right? So if you click on that link for Slack, you can actually get into an external workspace that Oracle developers have, and you can just chat with us there, right? So you search for the Oracle the Autonomous Database channel, right? All right, so this is the external workspace. So I'm sharing that link right now with you guys together, right? It was together with the links there. And anyway, join us there. I think it's going to be a great fun. You guys can interact with us, and we have product managers looking at them, right? So with that, I think that's a great opportunity here for me to stop. I'll stop sharing then and let you share your screen. Thank you very much for joining us today, Germán, and take it away.
Sure. Thank you, Marcos. I appreciate your invitation, and thank you for the poll, because I think it's very important to understand the audience and see, where we are in terms of Kubernetes. So let me share my screen. Let's get started. All right. So welcome, folks. Thank you for being here, and I hope this becomes a useful session for you. We are going to go through the Oracle Database Operator for Kubernetes, and we are going to actually install it. We're going to set it up. We're going to do lifecycle management of the Oracle database, of Autonomous Database. And so this is a very hands-on session. But first, I need to go through a few slides just to set the context, okay? So let's go. And first of all, I don't know how many of you are developers, but this is like a modern platform for, let's say, microservice-based application development. So you usually have an application runtime, and you have like a Kubernetes container engine. We have a technology called a.k.a. in OCI, where it's basically you create a cluster, you create a node pool, and you can have this runtime up and running. And this is the perfect foundation to basically run microservices. But sometimes, it becomes difficult to understand how can that cluster, that container-based environment can actually manage the life cycle of Oracle databases in a seamless way, and in a way which is very convenient for automation, for example, and for DevOps processes, CI, CD, etc. So this is a typical setup. As you can see, we have in the application runtime part, we have data, we have ATP, ADW, etc. We could also be connecting to storage. So you name it, we could do all sorts of things here. But if we don't have the right controllers to be working with this, databases, with storage, etc., our lives becomes more difficult because nobody wants to basically ask somebody else to provision the database, for example, when we need to automate all of it. Okay, so we obviously have security layers and observability and management layers at the bottom, which are super important. But we have developers that are familiar with this platform and are used to specific tools and are working with a specific tool. Here I'm mentioning like Micronaut, Spring, etc., etc. But then we have like, let's say, kind of tools to do DevOps, to actually, orchestrate things, etc. Like, for example, GitHub, which is, a repo system. But basically, we have Argo, resource managers, etc. So this is kind of the glue that we have there to do all the operations that we need to do. So if you are more or less familiar with this, what I'm going to show you today is how to basically orchestrate all the parts that are going to be talking to those instances there, ATP, ADW, etc., etc. Okay. All right. So I mentioned that we have OKE within the OCI, within the Oracle Cloud. So we are offering basically everything that you will see today can be done from within OCI. So this is a very important point because we do have the capability to provide this functionality of working with a Kubernetes, full-blown Kubernetes cluster and install the OraOperator in it, etc., etc. But I have to clarify that the cluster that I will be running today within OCI, in order to work with OraOperator and manage Oracle databases, doesn't have to be within OCI. It doesn't have to be OKE. This cluster could be in a different cloud, for example. You could be running the cluster in a different cloud. You could be running OraOperator in that cluster, and you can be managing databases and even database services that are sitting in OCI, like Autonomous Database, okay? So this is very typical when you are a developer, you're working with microservices. There's an approach where developers say, hey, let's use the best data store or the best databases for the specific microservices that we want to support. So, we have a microservice that is heavy dealing with documents. Let's use MongoDB. We have a microservice that is basically doing a lot of graphs. Maybe, I don't know, friends in a social network, something like that. Let's use Neo4j, and so on and so forth. So basically, you end up with multiple microservices, different database behind each microservice, and this is a big problem if you think about it. Why is this the big problem? Because you need to deal with, for example, suppose you want to deal with security. You have to deal with security for every single different type of technology. Suppose you want to do a query that goes across, all of these different instances where you need to aggregate, information. It's a big problem again. So when we are dealing with the converged database, and Autonomous Database is the Oracle converged database behind the curtains, we're dealing with a technology that is using basically a containerized approach, which is really nice because we're talking about containers today. We're talking about Kubernetes. And if you have containers on the application side and you have containers on the data side, you're basically working the same way, right? You're basically leveraging these capabilities of running, different things within containers. Like, for example, in the case of Kubernetes, you have pods, but in the case of the converged databases, you have PDBs, right, running in a container environment. And you can use all the capabilities of, basically managing the lifecycle of the container itself, so you don't have to deal with each PDB. One example would be patching, for example, or there are multiple other examples. Basically, you leverage that capability. And as you can see here, in each PDB, you can use a different data type. You can have an HAD, for example, where you are running JSON, you're dealing with JSON documents within the database. You might be using a different PDB that is basically doing graph support, right? You might have an ATP where you're doing, transactions, OLTP. But basically, you have the same underlying architecture. And this makes things really easy to basically interconnect if you need to do cross-querying. For example, here we have, like I mentioned, of TQ, transactional event queues, where we use this type of queues to basically do message passing, between what's going on in the different PDBs, okay? So this is the approach of the Oracle database, and it has multiple advantages. We call it the converged database. So let's go to Kubernetes, okay? This audience is probably very familiar with the converged databases, with autonomous database, et cetera, so I don't have to basically sell this for you. But let's go to the Oracle Database Operator for Kubernetes, and let's see how we deal with a containerized architecture, but on the application side, okay? All right, so for those of you that are not familiar with Kubernetes, at the center stage, we have like a cycle that you can see there, which is act, observe, and analyze. Because Kubernetes is basically working with specs. You define specs in a YAML file, and then the system is doing the cycle where it's trying to match and comply with the spec. So suppose that you create one of those YAMLs, and we are going to do this, where you generate an autonomous database, and you change that spec later. Suppose that you create an autonomous database using YAML with 1 CPU and 1 terabyte of storage, and then you change the spec to maybe go twice that, twice the CPU size and twice the storage. Now the system will try to comply to that spec and basically apply those changes automatically for you. So this is a nice thing. This is non-terminating control loop that we have in Kubernetes. We have service discovery and we have load balances, and the system is trying to maintain a state. Okay, so this is the important thing to understand about how Kubernetes works. Obviously, we have multiple pods and we have multiple systems. We can have, load balancers running there together with front-end UIs running there, which are also pods. And maybe one of those pods is an Oracle database image, just to give you an idea, right? So we can have like a big zoo of different things, but all of them working together, connected, working together, and with a really nice capabilities for doing automation on top of this, automated rollouts. You could basically create and destroy databases using OraOperator easily, et cetera, et cetera. One of the extra added points here, and this is something that we're going to see during the demo, is secret management. You have secret management. You can create config maps that allows you to connect to OCI, to allow you to pass all the secrets for the database, et cetera, et cetera. Okay? So why do we need a Kubernetes operator for the Oracle database? So what we want is the ability to deal with databases, Oracle databases, transparently from the Kubernetes cluster. It shouldn't be, special, the fact that you have an image-based Oracle database compared to a database that is running within OCI, like Autonomous Database. You just want to deal with the lifecycle of the database. You probably, if you're doing DevOps, you probably need to create it. You probably need to do your test, make sure that everything works correctly, and then you probably need to destroy it. It shouldn't be different how you work with the OraOperator depending on the type of database. So this is what OraOperator brings, and we will take a closer look at the different type of databases that are supported. This is a way for you to easily manage the life cycle of the Oracle databases within the application. So basically, these databases are connected to the application. I'm talking to the applications, and gives you the ability to create, bind, and do other things. And I'm going to show later, the type of lifecycle operations that are available. This is perfect for test environments when you're doing CI/CD. You're going continuous delivery, continuous integration, and you need to quickly spin up a test environment with maybe an autonomous database or a single instance database, to give you an example. You put it up, you create it. You can even connect this to a specific branching mechanism, like, for example, GitHub branches, and work with Jenkins, et cetera, et cetera. And the OraOperator is the connector with all your Oracle databases, right? It's the thing that is going to be managing the life cycle of them. Okay, so this is basically the purpose. As you can see there, I'm saying that you can do start, stop, monitor, patch, upgrade, et cetera, et cetera, et cetera. But we're going to go through a lot of these lifecycle operations during the demo. All right. So just to give you an idea, we have a command called kubectl, which stands for kube control. And every time you want to apply a specific spec or a YAML, you just do kubectl apply and the YAML. The YAML is human readable. You can basically, edit it. You can take a look at it, and you will see, for example, one YAML that helps you create an autonomous database. You can read it, and you can see, oh, this is trying to create an autonomous database. So this is perfect. You just do kubectl apply -f that YAML, and basically the system is doing everything for you. You just provide the spec. You don't provide the operations. Okay, you provide the spec of what you want. Now, the Kubernetes cluster, when it's running the operator, is running a set of controllers. These controllers are prepared to be talking to a specific database types. You could be talking to multi-tenant DBs, for example, that are sitting outside the cluster. You could be using like a database image that is within the cluster, or you could be talking to Autonomous Database, which is basically using OCI REST APIs to talk to OCI ADB service. Okay. Something is coming, and it's going to be very interesting, which is an observability controller in the Oracle Database Operator. If you tried out the Unified Observability Lab, where there are a set of exporters that are basically fetching metrics from the database, you saw the functionality. So this, I'm going to provide more details about this later, but this system is going to be embedded in the Oracle Database Operator. So with just one click, you will be able to say, I want to observe this autonomous database, and you will have all the infrastructure up and running in order to fetch all the metrics, all the telemetry from that autonomous database and send it maybe to a Grafana dashboard to give you an idea, okay? We'll see this later by the end of the presentation. Okay, so what is it that it is supported in OraOperator? We are in version 1.0.0. For the observability capabilities, we need to wait for version 1.1.0. And that's coming very, very soon, okay? So we have the ability to do the lifecycle operation of single instance DBs, SE, EE, XE, 23 free, for example, which was recently delivered. And we have a data guard lifecycle management capabilities in preview mode, create standbys, manual switchovers, stuff like that. The sharded database, which is really interesting, recently the support of Autonomous Database dedicated for the sharding service was announced. I think that was very interesting. And then we have Autonomous Database, both deployment types, serverless and dedicated. We can provision an ADB, we combine ADB, start, stop, terminate, scale up and down, which we are going to do during the demo. We're going to scale it up and down, network access options, and also backup capabilities, okay? Then we also have base DB and on-premises system with multi-tenant DBs, PDB, CDB-based systems. We can clone, we can delete, we can create, and you're using OraOperator all the time. You don't have to use anything else. And it's super easy to install, and I will show it to you in just a few minutes. Okay, Oracle Database Operator for Kubernetes DevOps CI/CD. What OraOperator solves for DevOps is, if you're doing DevOps, you're a developer, you don't want to wait for a DBA to give you the database, right? So you need to test a microservice, and you need to go talk to the DBA, try to get permissions, maybe create a ticket. So they create the database for you. You wait for the database to be created. You have the database. You try out the database. Now you want to destroy it, and you need to create another ticket, ask for the DBA to basically go destroy the database for you. So big mess. This is not what we want. If we are doing DevOps, we want to automate all of this ourselves. We want to use OraOperator, and we want to basically create a database, test the database, maybe change the schema or try with different schemas of the database using maybe a branching strategy to create a feature branch and work with that feature branch. And then I might just want to delete that branch in GitHub, for example, the feature branch, and get everything destroyed automatically. This is what this technology provides. And this is something that it's also supported, okay? So this is the basic solution. Automation for the lifecycle management of the Oracle database when you are developing applications, and especially when we are dealing with microservices-based applications running on top of Kubernetes clusters. This is the advantage, and this is the ideal setup. All right, so I mentioned branching, right? You might want to set up GitHub hooks when you have an application, and you might want to have those hooks talk to Jenkins, okay? When you create the branch, you can connect it to Jenkins. When you delete the branch, you can connect it to Jenkins, and when you push a branch, you can also, be talking to Jenkins. Now you can configure Jenkins to basically talk to the operator and do something with the database, the underlying database when that happens. You can have Jenkins create a database, maybe an autonomous database using OraOperator, and you can have Jenkins destroy it when you delete the branch, okay? So this is part of the lab that I'm going to show today. We're going to do lab 2. I'm going to give you references to the live lab. We're going to do part 2 or lab 2 within that live lab. This is lab 3 of that live lab, okay? If you just want to do everything I do today and then go ahead and do lab 3, you can go ahead and try this out, okay? In any case, I would like to deliver like a part 2 of this session to basically cover this. I hope I could do later, okay? All right, so I mentioned observability, and this is the last part of the deck, and we go straight to the demo, okay? I mentioned that we are going to release a cloud-native observability controller in OraOperator soon. So how does it work? What does it mean to do observability? There are 3 pillars of observability that are, the most important pillars. These 3 pillars are tracing, metrics, and logs. So every time you're dealing with observability, the most important things that you want to do is, metrics, telemetry. You want to know what's going on, maybe performance metrics coming out of the Autonomous Database. You want the logs because when you want to understand what's going on and you have an issue that is high level, you want to drill down and you want to understand the root cause. So if the root cause is in the database, for sure you want to go all the way to the logs, okay? And then you have tracing, which is basically what brings all of this together. Tracing allows you to go from maybe a high-level thing that is happening in the application all the way, drilling down all the way to the logs and trying to do some horizontal view of what's happening with the system, not just at some specific level, okay? So this system is basically using OraOperator to connect to the database, and it's using OraOperator to deploy specific pods within the cluster that provide all the glue to send telemetry to Grafana. So this system creates a set of exporters that basically programs that are running in the background, extracting telemetry from the database, right? And making it available to specific open standards-based tools like Prometheus, Grafana Loki, and Jaeger, right? So Grafana Loki is basically understands logs. Prometheus understands metrics, in time, because it's a time series database, and Jaeger understands tracing. So once these exporters provide the information or the data for them, these endpoints that are also sitting within the Kubernetes cluster are ready to send the data to Grafana. Grafana connects to Jaeger, to Prometheus, and to Grafana Loki, and it's able to create really interesting, dashboards for you. So this is what this is all about. This is about use cases like troubleshooting, performance tuning, alerting, and it's very custom. You can create your own dashboard. You don't have to go with a specific, prefix dashboard that is showing maybe, I don't know, CPU utilization, but you can basically go ahead and create your own dashboard, and you can extend the metrics. You can go to the metrics exported, for example, and you can add your own metric there, and you have that new metric that you can reflect in the dashboard, okay? So let's go to the demo. The demo have some prerequisites that I already did, which is running lab 1 of that live lab that it's up there, Oracle Database Operator for Kubernetes plus DevOps. We're going to do lab 2. You have a bit.ly link there in the top right, okay? But what I did is I basically created the cluster, and I did nothing else. So I have an empty cluster that is running in OKE. It's up and running, okay? And I initialize the cluster, and that's it. What we're going to do is we're going to install Cert Manager, which is a prerequisite to manage all the authentication. And then we're going to install OraOperator. We're going to create credentials. We're going to generate the YAML for ADB creation. We're going to generate the wallet on OCI. We're going to bring back the wallet to the cluster. We're going to initialize ADB for Cloud Bank. We're going to scale ADB so we can see how we can scale up and down by working with the spec. And we are going to extract the wallet locally, and I'm basically be working in Cloud Shell to give you an idea. We're going to extract the wallet locally to connect to the database, and I think that we will be done there because we won't have time to do part 8. All right, so let's go. And here I'm basically in Cloud Shell. You have to go here, and do Cloud Shell. And this is basically your own local, command line that comes pre-configured with the OCI CLI. It has all the tools that we need within Oracle. It has SQL CL, SQL Plus, et cetera, et cetera. So as you can see, I have a database that has been terminated. So I have no database. So what I'm going to do right now is I'm going to install Cert Manager. But before doing that, let me just give you an idea of what the cluster looks like right now. So I'm going to do kubectl get nodes. These are the nodes that I have. I'm going to do kubectl get pods all namespaces, and basically you see that I have a kubesystem up and running, DNS, DNS handling, proxy, etc., etc. This is all ready. I'm going to be using CloudBank, which is a demo microservice application that we have, and I created a namespace called CloudBank, and in that namespace we have nothing. Okay, we have no resources, and we will be putting resources in this namespace. So first of all, I'm going to install Cert Manager. Cert Manager doesn't belong to Oracle. It's part of a Jet stack, and I'm going to use kubectl apply in order to do that. Okay. So what I just did here, let me go just full screen, is I did kubectl apply of a YAML file. And with the YAML, you can actually extend, when you do one of these applies, it might be a tool that actually extends the Kubernetes API. And this is what is happening right here. When we do the same apply for the OraOperator, we'll be extending the Kubernetes API, okay? So let's go ahead and see if Cert Manager is properly configured. Okay. So as you can see, you should be seeing ready 1.1 in all of the 3 instances here. Cert Manager is ready. So this is our prerequisite for installing the OraOperator. Now I'm going to install OraOperator, and this is basically installing a YAML that is sitting in the GitHub of OraOperator. I'm going to share the GitHub of OraOperator if you want to contribute later. I'm going to share a link, but basically we just go to that YAML that is prepared to install OraOperator. So we just did kubectl apply -f OraOperator, and OraOperator is installed right now. So we have OraOperator in our cluster. So it took me like, I don't know, a few seconds, right, to get this up and running. So it's very, very easy. So suppose that we want to verify if this has been properly deployed. I'm going to run get pods, and I'm going to ask for the Oracle system. And as you can see, we have them here, and we have 1.1, which is up and running. If you see 0.1 here, it means that you need to wait because it hasn't been properly deployed yet. You should continue when you see 1.1. It's basically up and running, available. Now let's take a look at this. Okay. Oracle Database Operating System. Okay. So as you can see, here we have the first part that I already showed, but also we have services. We have a controller manager metric service. We have a webhook services. These are all having internal IPs, private IPs within the cluster. So these systems are available for us to connect from within the cluster. We can use them. All right. So let me keep going. So what is it that how did we extend the Kubernetes API? So if I do this, and I list the resources at the API level for the API group database.oracle.com, now I have this API group that is basically allowing me to operate over autonomous container databases, autonomous database backup, autonomous database restore, CDBs, data guard broker, etc., etc. So wow, we now have the ability to work from within the cluster with all of these types. And you might be familiar with these types already, the single instance database, autonomous database, etc., etc. So now we have the tools to basically work with all of this. All right. So first of all, what I'm going to do is I need to have OraOperator talking to OCI. So what I'm going to do is I'm going to create a set of info, which is basically credentials, so OraOperator can connect to OCI. And for that, I'm going to create a config map. You can see here that I do kubectl create config map for OCI credentials. And I'm basically passing the tenancy ID, the OCID user, the fingerprint of the API key that I used to connect to OCI, and the region identifier. Now, this is convenient because I don't have to provide this in environment variables if I want to do something. This is now in the cluster. And this is one of the nice things that a Kubernetes cluster have, which is, management of credentials, management of secrets, etc., etc. So I'm tapping into some environment variables that I created before in Lab 1, because in Lab 1, there was a part that was asking you to provide this tenancy information, fingerprint, etc., etc. That was put in environment variables. So this is just fetching those variables that you provided in Lab 1 in order to create a config map. Okay, so we have the config map. And what I'm going to do is just create a secret pointing to the private key of the API key. So I previously created in lab 1 an API key within OCI. I need the secret, of that API key, and this is what I'm going to do. So basically, I do kubectl create secret, and that's the key to create a secret within the cluster. And I'm pointing to the private key of the API key that I created. Okay, and I'm always working within the Cloud Bank namespace in the cluster. So now I'm going to do the same, but for the secret of the admin password of the database, okay? Admin password of the database. So I can also put it there. kubectl create secret generic admin password. I previously provided the password in lab 1, okay? And it was stored in an environment variable, all right? All right, and now what I'm going to do is I want to show you a YAML that creates an autonomous database. We should be up and running. So there's a functionality in this lab that actually creates the YAML. So I'm going to ask this shell script to create the YAML, but don't worry because we're going to take a look at it, okay? So this created the YAML and told me, hey, you can apply it by doing minus, kubectl apply -f on this file. So let's take a look at this file. So basically, we have a spec here saying I want an autonomous database here in the Cloud Bank namespace. This is the compartment OCID. I'm working in a compartment called Kubernetes compartment. This is the DB name that I want. This is the display name. I want 1 CPU core, and this is the admin password. Remember that we just provided this in a secret. I want 1 terabyte of storage in the database, and this is the credentials to connect to OCI because I have to go to OCI to request, this creation. Okay, but OraOperator is going to handle that for you. Okay, so very, very, very easy. I'm going to exit, and I am going to just apply it. But before applying it, I'm going to do this. I want to see if we can see it here. Okay. Okay, I'm applying. Apparently it's okay. So as you can see, we see provisioning here. So it took 2 seconds to get into the OCI console. That was very, very fast. And now what I'm going to do is I started a creation and I want to take a look at what's going on. So if I do kubectl get autonomous database, I see that I have a database being provisioned right now. It's not dedicated, it's serverless. It has 1 OCPU, it has 1 terabyte storage, and it's OLTP, okay? This is ATP. And it's provisioning right now. So what we're going to do is we're going to wait until it provisions. It should be around 2 minutes to give you an idea. But we're going to describe this database with a kubectl command. Describe command gives you more information, much more information than this. So let's describe it. And let's go full screen with this. Okay. So as you can see, we have an autonomous database OCID now. We see here that it's provisioning, okay? We have details. We know that it's bring your own license, the lifecycle state, et cetera, et cetera. We have 1 CPU core, 1 terabyte. So basically, this is the description of the database. Once it is provisioned, this description will also provide the connection strings for the database, which I think is very, very interesting, okay? So they are not there yet because this has not provisioned. So let's go back, see how we're doing. Okay, it's available now. Let's see if I was right about the connection strings. Yeah, there you go. Now we have all the connection strings for this autonomous database, right? So let's keep going because I have a couple more interesting things to show you. Now what I'm going to do is I'm going to create the wallet secret. This is the password of the database instance wallet that we will use. So let's do that. Because OraOperator can also handle the wallet for you, the database wallet, okay? So I'm going to create this secret here. What I'm going to do is I'm going to use a YAML that will create the wallet, okay? So I'm going to generate a file called ADB wallet, and I'm going to show it to you. So we have some convenience script within the lab that generate those YAMLs for you, so you don't have to go and create the YAMLs manually, okay? And basically pre-fill some of the information there, like for example, the compartment, OCID, etc. Let's take a look at what this is doing. So this is another YAML that we are going to apply in the OraOperators. Same as we did for the database creation, now we're going to apply this one for the wallet. So what we're saying here is, I want you to work over this autonomous database OCID. I want the instance wallet, and this is the password that you should use for the wallet, okay? So let's get out. And let's do kubectl apply. Okay. Okay, there you go. It's been applied. And now let's verify. I'm basically saying, give me the secrets, but filter for those that says instance wallet, right? So there you are. Seems to be okay. So now what I'm going to do is I'm going to init the database, and I want to show you this init database shell script. We have everything that we need. We have the database, we have the possibility to use the wallet to connect to the database. Now we need to initialize the database for supporting the Cloud Bank application. So as you can see here, the scripts is basically, getting the wallet to connect. What it will do is we'll run some SQL scripts within the database to create roles, create users, create tables, etc. We're going to apply it, and we're going to take a look at the log, okay, of what's going on. So let me see if I can exit. Okay, I'm going to, there is fetching the wallet. It will run some SQL in the database. And now let's take a look at the log, okay? So the logs were in, I think they were here, logs. Okay, and I'm going to do, the SQL setup log. So as you can see, what we did is we created user, we did several grants here, created the bank A user, bank B user, ran some stores procedures, inserted some rows, created the bank user B accounts table and the bank user A accounts table. And here we just put money in those tables. So it's basically a system that moves dollars from one account to the other. Okay, it's a it's like a toy microservices-based application. Okay. So this is what was done. This could be in a DevOps setup. This could very well be trying out a feature that we're working on, working with the database, trying a feature, see if everything works correctly with a microservice, and then we could proceed to destroy the database, okay? So let's do a scaling exercise now. So I have this file that I created myself. It's called scaleadb.yaml. What this is doing is saying, okay, I have an autonomous database in the Cloud Bank namespace. This is the OCID. The OCID I have to replace because this is from a previous run. We need to put in the OCID of our current database. And I want to go CPU core count 2x and data storage size in terabytes 2x compared to 1. So 2 CPUs, 2 terabytes. So this is what we're going to do. I'm going to delete let me just copy the other OCID. Just one sec. We are almost done. Okay. We need to describe. This gives us more information. Now I'm going to copy the actual OCID. Okay. I'm going to delete this OCID. So, okay, so we have the file and we have the OCID there, and now I'm going to just apply it. Okay.
And we have another question here. Are these Kubernetes manifests idempotent? For example, if you change the auto scaling or cores, will they be non-destructive?
Non-destructive. Can you clarify? Like I'm not sure. Basically, if you change the spec, I'm not sure if I'm answering the question here, but if you change the spec, the spec will accommodate the modifications. So basically, there's a control loop coming back to the spec all the time.
Right. So in case of the autonomous database, then I think the idea is if you say I want now two CPUs and 2 terabytes, the idea is that you're not destroying the previous one, right? So you're just asking the autonomous database to scale, right, and change the scale. Yeah.
Thank you for the clarification, Marcos. In fact, you can actually patch a spec. You can, if you just apply the YAML, you do not destroy it as long as you have the same OCID. But you can also not use a YAML. I'm going to do this right now in a few seconds. You can patch the spec and bring back the scale to maybe one CPU, 1 terabyte. Okay. So I'm going to go here to show you. Okay. And I'm going to just apply the scale ADB. So it says configured. And here we see scaling in progress, okay? So it just came back to the OCI console. We are going to wait for it to scale. This should be fairly quick for this type of scaling. But what we are going to do is as soon as we are done with the scaling, we're going to patch it. And the patching works like this. I'm not going to hit enter right now, but you can see that with this line, we are not working with the YAML, and we are saying, kubectl, I want to patch the spec for autonomous database in the CloudBank namespace. And I want you to go and touch the CPU count, CPU core count field and the data storage size in terabytes field and put it back to 1. And I want you to do a merge, okay? So you merge it with the rest of the spec. Because with the merge, you make sure that the rest of the fields stay the same, okay? Of the, let's say, properties, not fields, okay? So the rest of the properties stay the same, all right? So let's wait for the scaling. And actually, we could just use the opportunity to describe here, because
and real quick, while you're describing that, another question came in saying that could you do the same exercises that you just did on premises as well with local databases and 23C or 19C, or is this only in autonomous?
Exactly the same, basically unchanged in terms of the commands that I'm sending, but obviously changing the YAML, because you don't operate over autonomous database, you operate over other type of databases, and but basically that's the power of it. All right, so
right, and I think what you're doing is you're using autonomous just for convenience here, so that you can see all the instances there.
I'm using autonomous because I love autonomous, right? So that's why I'm using autonomous.
That as well. That as well.
No, that's very easy to deploy. Okay, so let's go and do a patch. Okay, now this has been put to 2 and 2, as you can see there, and now we are just patching the spec. We are not using a YAML, and we don't even need to provide the OCID. We just take the autonomous database that we have and we patch it. Okay. So it's been patched, and there we have scaling in progress, and now it's coming back down to 1 CPU and 1 terabyte. So this one more thing that I want to show you, and I'm basically done. I hope that we are on time, but this is very, very quick, okay? What I want to show you is how to extract the wallet locally here to Cloud Shell from the cluster, and then use the wallet to connect to the database. Manually, we're going to use SQL Plus, and we're going to connect, okay? And I'm done with the demo. So let's do that. Let's source this file. Hope that I can do this while it's scaling. I think that since this is related to the wallet, it shouldn't be a problem. So let's do this. And I'm going to show you what this is about, this shell script. I created this shell script. Okay, so let's wait for it. Okay, so I'm going to show it to you. What I'm doing here is I'm bringing the wallet locally to the, basically creating TNS admin locally, okay? I'm bringing these files, TNS names, Aura, SQLnet Aura, cWallet, etc., etc., etc. But the way in which I do it is, instead of just using some API to go and fetch it from OCI, I'm basically asking the Kubernetes cluster to give me the secret, okay? Because this is now in the cluster. So this is, you need to do a base 64 decode for the files, but you basically have it in the cluster because the cluster has the secrets, okay? So this is what I did, and now I have the wallet local. Now what I'm going to do is I'm going to show the name of the database again. And I'm going to do SQL. I'm going to do admin. Remember, in Autonomous, we have admin. And I'm going to use Medium, for example, okay? Because now I have the wallet, I have my TNS admin set up, okay? So I can actually do this. Okay, let me see if everything is okay. Okay, asking for the password. Okay, so we are in. And now what I'm going to do is I'm going to try to do a select to check on the users. I have the bank A user, for example, there at the bottom. And I'm going to run this query to take a look at the tables. We have accounts, okay? And now we're going to do a select on this accounts table. And you can see, as I told you before, you have basically dollars here in the account value. So here you can exit or quit. So the part 3 of this lab is basically deploying the microservice on top of this database, okay? I'm going to quickly switch back to we're basically done with the demo. I hope it was useful to you. I think that gives you an understanding of how this works. You can do more lifecycle operations. For example, you could go to backups, but basically the demo is not a super complex demo, and you can do it at your own time later and by just following the live lab. What I'm going to show you now is a little bit of, let's just go to these slides, because I want you to know that you can contribute to OraOperator, okay? You can go here to this GitHub, and if you want to add a lifecycle operation that is not there, you can actually go ahead and contribute. You can get it from here when the observability controller is available. I think that's going to be very, very exciting. But please feel free to just check it out, and there are more demos within the repository, etc. I also want you to show you this. I think this is very important. We have other very interesting live labs. We have one that is specifically crafted for DBAs. If you are interested about Kubernetes and you are a DBA and you don't have like a strong developer background, et cetera, you come more from a DBA background, you should definitely take a look at the first line in the slide and go to that bit.ly link and do this Kubernetes for DBA live lab by John Towers. An ex-DBA, so it's definitely focused on that specific background. But then you also have another interesting live lab, which is here you can see want to some hands-on fun, set up an environment and build a Cloud Bank application. So there's a Cloud Bank, a specific live lab that you can use. It uses Converse database. And what is very interesting is that it uses Spring Boot JPA. And I'm not sure if you're familiar with our announcements around Spring Boot and around PARS, for example, mobile backend as a service, but it's a great opportunity to go ahead and try this out, okay? So don't miss the opportunity to go ahead and check these two excellent live labs from our folks at Oracle, our colleagues. All right, that's it for me, Marcos. Thank you very much.
Excellent. Really appreciate it. Thank you very much, Germán. It was great. One question still remaining here is, are there any mistakes or errors that you see users encounter? Maybe that's probably the common mistakes, right, that people might make when using these.
When using OraOperator, you mean?
Yeah, I believe that's
Yeah, the difficult part is to making all the posts work together, okay? So each service is basically exposing IPs for it to work, with different systems. So orchestrating all the pods is difficult. When you take a look at this live labs, for example, you have a lot of shell scripts that are basically connecting and doing all the glue for you to connect all the pods. So that's the greatest struggle, I would say. So in order to tackle this problem, my advice is that you understand networking a lot, VCNs, networking, how to connect things together, how you can deal with private networks and public networks, et cetera, et cetera. So it's more of an issue related to understanding networking than actually understanding Kubernetes, because Kubernetes is not complex. It's like a mini Linux systems, running all together inside a container, and then you have to get them talking.
All right, excellent. Okay, so I ran the poll, guys. Thank you very much for a reply. I think, Germán, you basically, that was great. A lot, around 30% of the people had some background on the topic, and the awesome. Session gave them confidence to understand it well. 36% saying they did not know about the topic before today. And we have still 9% of the folks still not clear, which is, I think it's okay, respectable. We expect you guys to, probably use the live labs, right? That you shared. I think those are great.
Yeah, I highly advisable that you go through them, because you can set everything up by yourself.
All right. Okay, so excellent. Really appreciate, guys, you answering the polls. I will share the slides, yes, after the session. So to make sure, if you guys want to see, more of the slides and the different things, here again, to everyone, I'm sending you the important links, right? So if you look at the chat, I'm pasting the links there for you. So the recording, everything that you guys saw today is going to be on the external sessions, right? The same way that you guys joined today. So the recordings and things like that's going to be on the ADB Learning Lounge. I'll leave these things open. So if you guys still have questions, feel free to type your questions still in here, right? So Germán can still reply to you guys. Final thoughts again. The upcoming sessions. Go back. Make sure that you go back to this link and check it out. So I'm going to be announcing the next sessions for potentially for next week in the site. So you guys are going to see it there. Okay. And well, that's it. I really appreciate, again, thank you very much, Germán, for joining us today. It was a great session.
Thank you.
Guys, keep an eye on for the sessions that are coming up. And that's it. So again, I appreciate it. Thank you very much. I'll leave this open for a few minutes if you guys want to add yet another question there. All right. Okay, perfect. Thank you.